On the bench today we have a Cobra 148 GTL. This is definitely an older one. Customer said he thought he bought this, he's the original owner to this, thought he bought this like in the late 70s, early 80s somewhere. Looking at date codes on ICs and this, I'd say probably late 81, 82 is probably when he got it. So yeah, it's side mic radio. Originally he had, I'd have to grab the note here. I think originally it had, let's see here, channel mod on some of the switches. Yeah, it had a channel mod on the high-low and the bright-dim switch, and he also had an alignment done at the time, or he had a tune done to it at the time. And he used it for, I guess, decades like that. And as you'd expect from a Cobra 148 GTL, it was a good working radio. So I guess it got put off to the side at some time, and then he sent it to somebody to have some work done to it. So it has had a lot of work, and actually the note here says, here's what was done. I like how he put this. I had a, in quotation marks, tech do some work to the radio, and it hasn't been right since. Well, the guy was obviously a tech. He's no moron. Just I can look at parts that were used, and we'll get into some of the other stuff that was done, but channel expansion that was done to it. Yeah, it definitely wasn't some guy in his backyard who works on a radio once every 2 years. But so he says, here's what was done. Recapped the radio, tuned and aligned, receive mod, don't know which one in particular, used radio PA switch for power, radio 4 watts, PA is 2 watts for running into a linear, 10-turn clarifier, disassemble and cleaned tuner assembly, and yeah, it does look, I can see that the rivet on that. No, it's not really a rivet. The rearmost section on these switches has little ears that stick out. They go through this metal plate, and then they're melted on to hold, kind of sandwich them together. I can see that's been tinkered with. So somebody probably had the channel selector apart to clean it. And let's see what else. Replaced PLL, corrosion on old pins. Replaced finals, plural, with 2SC22, bleh, I'll get it right, 2SC1969s, installed frequency counter, and installed LED on meter. When I sent the radio to him, it was stock with the 2 exceptions. Yeah, the channel, the original switch mod, and the clarifier was unlocked. That was the other thing that was originally done to this. So appreciate me checking it out. See, basically, what's the scoop? Because he says receive on this thing, it just ain't right anymore. So I did speak with him about this, and one of the things he's noticing is on receive, with the squelch turned up, there's still noise coming out of the speaker. That's going to happen. Now, I can probably get it knocked down a little bit more, but that's still going to be there, and the reason is because of the frequency counter. So there's actually 2 things inside of this box. The first one is the channel modification. So this is a channel modification that's made by Ralph, or Backwoods RF. I've seen these before. Maybe not this exact version, but anyhow, I've seen his channel expansion boards. They just use the original PLL and basically interrupt the channel selector. So you can use either or. You can use the factory channel selector. You hit the button on because this is a rotary encoder with a push button function. So if you hit the push button, you can use the normal channel selector. So normal 40 channels. You hit the button again. That disables the channel selector, and then you can use the VFO knob here. Actually, let's just take a look at that. And I'll get this couple Phillips screws here. And I have to say, I am liking my new fellow screwdrivers that I have here. My recent spending spree buying tools and equipment and parts and everything. I'd gotten a complete set. I've been spoiled with Mac and Snap-on tools for decades, and I thought it was time to get a new set of screwdrivers more designed for electronics, and got the Fellow screwdrivers. They're made in Germany, and I like them. I really do. They're good. The screwdriver tips fit really well, on properly made screws. And these are maybe a Chinese box. I'm assuming the project box is probably made in China, but the screws apparently were good because really good tight fit. But yeah, just a side note there. Yeah, I'm liking these Fellow screwdrivers. So in any case, so inside this little box, his channel modification is actually 2 boards. So we have the microprocessor over here, which is an Atmel. I gotta pull it up here to look at it because I can't. Trying to read that laser printing on there. God, what is this? An AT89C. What is it? 2051. It looks like. So, shoot, you probably read it better than me. Once I zoom in on it there, yeah, I can see that even in the viewfinder now. So, any case, and you can see there is a crystal in there. That's for the PLL and all the supporting components. But that's the channel modification. This board and this board over here, and then this board actually still has an 8719 PLL on it, and also has a CD. God, what is that? Like a 40. No, it's a 4090 something. CD 4094. Oh, actually, if I just look through the viewfinder, I could see it very clearly. I keep forgetting how well this camera zooms. So any case, and this is the other part of it. It's not actually 3 ICs. There's actually 2 ICs here. You have the CD 4094. You have the original. Well, I don't know if it was original this radio. Yeah, as old as this radio is, it would have had an 8719 in it. That is not integrated circuit. That's actually a resistor. Yes, they do make. They make what they call SIP or DIP. So SIP is SIP, single inline package, or DIP, like an IC, is dual inline package. But inside of that's just a bunch of resistors. It's a very convenient way to get a lot of resistors in a small space. But and then this also has a Sangen. I think that's how it's pronounced, Sangen Studio or something like that. I actually have these and I use them. They Sangen, whatever it is. You get these little frequency counters modules on eBay. This is a 6-digit. They also make an 8-digit. They work really well. I can't complain about their functionality. The only problem with them is they're noisy. They work well because there's only 4 wires to hook up. A positive and a negative power supply source. And the cable to feed in the frequency into the counter module. It's self-contained other than that. It's got its own voltage regulator circuit, which does run a little bit warm. Honestly, if you run it at 13.8 volts off the radio, if you can step it down before it goes into this, that'll actually help a lot. And that actually tends to help with the noise that's being injected into the receiver of the radio. Running that through, or lowering the power to this can help filter out some of that noise because you're running it through another power supply circuit. But the reason they're so noisy is they're PWM, or pulse width modulated driven. So actually you can just see it right there. So these are so you can see there's 3 digits, but there's 2 modules. Each module has 3 7-segment displays in it. But if you look down underneath there, you can see there's other components sandwiched in between the actual display and the circuit board. So there was actually an LED driver in there. The problem with LED drivers compared to, let's say, what was originally in this radio, the normal LED channels display, the display over here is just driven by, well, it could be grounds or the channel selector, depending if it's a common anode or a common cathode display. But it'll either have voltage supplied to it continuously, and then the channel selector, 1 or 2 of the wafer sections in this switch will supply grounds to different pins to illuminate different sections in the display. Or it can have a common ground and the channel selector will supply voltages to the pins of the display, but they're directly driven off voltage. There are dropping resistors. They don't operate off 13.8 volts. That's why there's always lots of resistors here. But that's it. There's nothing digital about it. It's just voltage. It's no different than an LED just like that. You know, same exact thing. These aren't like that. These are driven pulse width modulated. So it's very noisy, or there's a lot of digital noise. And these things are horrible. I've put these in base station radios, and I'm here to tell you, it is a chore. I mean, it's just a feat trying to get rid of all this noise so it doesn't bleed into the receiver. And it's pretty much, I'm not going to say it's impossible, but within practical means, it's darn near impossible to get rid of all of it. The noise will give you like probably somewhere between an S6 to an S9 signal level if you just hook it up to a radio. It's that bad. You've really got to add some filtering to these things. Now honestly, this one's not that bad. You really don't notice it unless you have the squelch on or you turn the volume down the whole way, and you'll hear the bzzz, you'll hear that digital buzz that's being caused by the display driver unit in there. Now it looks like they did take care of some of that. Get the board over here unscrewed. They did add some ferrite beads. What, one or two? Yeah, there's two. So there's one here. So there's a ferrite on the main cable that comes in, and then they also added a ferrite bead down here with 3 turns on the power supply line that goes to this board, trying to keep that noise from getting out of the board and into the radio. And like I say, it's actually, that worked pretty well. I mean, I'm surprised with just that. I guess actually the big benefit here is this isn't in the radio. That's the problem when you mount these things in the radio. You know, electrically it's really close. When you mount it externally, yeah, it's got, you know, especially when the cover's on the radio, that helps to add some shielding. So the only place that the noise can get in is through the power wire. So, but yeah, I'll try and get that knocked down a little bit more. It's to the point now, I think really all it probably needs is a little bit of additional reservoir for power supply, so filter caps. It just needs a couple extra electrolytic capacitors added. So on this one, I don't know, I might be able to, I gotta check the size on these. I might be able to actually increase the size on these 2 surface mount caps here. I'll have to check the footprint on that. But if not, I can add another cap right here on the board. I've done that before. Actually just remove the power supply connector, install a electrolytic capacitor where the power supply connector used to be, and then attach the wires. Just take the plug off the end of the wires and then attach them on the opposite side of the board there. That adds a filter cap right at the module. That'll help to catch a lot of that. That'll really reduce the noise. And then add another one probably over here somewhere. The one suggestion I might have for Ralph himself is, and this is actually the first time I ever saw one of these, someone had bought one of his boards, sent the radio to another shop, and they couldn't get it to work. They tried and tried and tried, and they eventually just gave up. I've done work for this customer. He just took it to this guy because he was local. You know, he just basically throw the radio in the car, drive down the street, hand the guy the radio. Where if he's going to send it to me, he had to send the radio. You know, he actually had to ship it to me. So, you know, last resort. So he did. He shipped me the radio, and what I found was Ralph actually makes his own boards. And Ralph, if you're watching this video, I would recommend getting them professionally made. Boards are so cheap nowadays from China. And they're not cheap junk boards. It's what Mark uses on his channel boards. They come from Elecro. They make really good, high-quality boards. They can make multi-layer boards. I mean, custom silk screening, you know, through-plated holes. I mean, it's just so much nicer. And the problem I found on that first one I ever saw was, the reason it didn't work was, when I say Ralph makes his boards, he literally makes his boards. He does his own etching. So the boards are etched in an acid bath. You know, he does it himself. You know, applies the photoresist on there, and then you dunk this in an acid bath, and then you rinse it off, and it eats the, you know, any copper away. The problem is either the boards were left in the bath too long, and it literally just ate some of the traces in half, or it's just the photoresist material that was added to the board there just wasn't adhered well enough, and it got underneath of it and etched it. But even this one, I can see it looks like there's probably been some repairs to this thing. You can see there's solder here, so I'm thinking maybe that might have had problems. You can see there's kind of some solder bridge work here. You know, it just, yeah. And actually, I don't know what the hell's going on here. It's green. That's corroded. Yeah, I'm going to have to clean that off, because that's just going to end up eating the little bit of trace that's there is going to end up eating that in half. But yeah, that would be my suggestion, Ralph. Your boards work fine. There's nothing wrong with them. It's just that these thinner traces, it's hard to, it's kind of hard making these yourself without eating through them. So get some professional ones made. It's so cheap. Just send them the file on this thing, and they're cheap, man, and they're fast. Their turnaround time is amazing. You'll have your boards in your hand in like a week and something, probably. So I've looked over the radio, just giving it a quick once-over. I haven't gone over it in complete detail, but yeah, I can see it still needs some help. For starters, whoever was in charge of the glue pot the day this radio went down the assembly line, glue must have been on sale that week, because that nasty corrosive glue they use in radios, man, were they ever generous with it in this one. I mean, wow, this has got to be one of, I'm not going to say it's the worst, but it's one of the worst glue jobs I've ever seen. Man, they just gooped this thing up everywhere. Now, whoever worked on this took the glue out somewhat. I guess they did a quickie job. Honestly, it's what you usually see. They just kind of scrape out the big chunks, and it's about all the farther they go. So, if we look down in here, you can see the wires are still all corroded back here. There's still glue on the ferrite. It's down inside. These are just wires. Just remove them. Just desolder it. Throw it away. Just take a, that's the main reason I keep... Now, granted, I recycle it. I recycle everything that's recyclable, but I keep all my terminal cutoffs here. These are great for that. If you work on radios for a living, I mean, obviously you've replaced all the electrolytic capacitors, so you had a bunch of these little cutoff leads. Just make new wires up. It doesn't hurt the ferrite beads. Just pull the old wire out. It's corroded. It's nasty. You're never going to get everything cleaned off of it. Just remove it. I mean, like this big one here, you can see there's still glue down on the board. The core of that ferrite's still filled with that glue. It's just going to still eat that wire in half. There's other places in here where the glue was never removed, it looks like. Like there, right there. There's still glue all down there. No attempt was even made to take that glue out. There, it's still nasty, man. Yeah, you can see the scratch marks where some of the glue was removed, but it's still down in the hole there. The ferrite bead is still filled. It's still all over the lead of the capacitor. Right there, that glue's never been removed. That was never touched. There's still glue all over the lead of that diode, all over the capacitors. Yeah, I'm going to have to spend an hour. It's probably literally going to take an hour or more cleaning all of this crap out of this radio. Oh, God, I just hate that stuff. Other than that, it doesn't look like, I can't even remember if I don't think it looked like it was overmodulated, at least not too bad on a scope, and I did a quick radio check on this. But yeah, it's got some audio mods. They just need to go. That should be green poly dip. That should be a green poly dip. Should be a green poly dip cap. I can see resistors obviously have been changed because they're blue. And this radio did not come factory with, there's one right there. There's one right there. Where else did I see? Oh yeah, there's a pair of them paralleled together. I'm not sure why. Maybe he just didn't have the right value resistor, so he paralleled a couple together there. Yeah, they're not factory. I'll I'll need to undo this audio, these audio modules, that little box capacitor there. There's a bunch of them in here have been changed, so I had to go through that. That's, you know, broadening your audio a little bit is fine. You know, receive and transmit. There's a fine line you walk with broadbanding and practicality. You know, you would love to have as broadband a radio as you can have as far as audio bandwidth goes. For starters, the problem is this is a CB. The channel spacing is 10 kilohertz. It's not 25, it's not 50, it's not 100 kilohertz. So you have a very limited bandwidth to start with. The instant you get out past 5 kilohertz in either direction, because you have to remember, even though the channel spacing's 10 kilohertz, that's an AM carrier with 2 sidebands, okay? So you can own, so this is the center, okay? You only have 5 kilohertz from here to the edge of the channel in either direction. You have your lower sideband and your upper sideband. And like I say, there's only 5 kilohertz worth of usable range there. The instant you get out 1 hertz past 5,000 hertz, you're into the adjacent channel. You're splattering. The problem when you're transmitting. Now on receive, the problem is you end up letting in more noise. It's like opening a little hole and letting just a specific signal you want through, or opening the barn door and everything comes in, and that can add a lot of noise to the receiver, which is one of the things this guy's complaining about. Not just that noise when it's down, but he said it just doesn't sound right on air. It's too noisy, you know, even with the volume turned up. Broadbanding the receive audio will do that as well. So yeah, that stuff's just going to go poof. It's going to go away. Yeah, I tinkered with that years ago. Did it to a few radios, and yeah, it's just a bad idea. I just learned my lesson early that stuff like that's just, it's a good way to get money out of people's wallets, as I often say. So let me get to it. Oh yeah, the channels that had originally been installed in this, it looks like that had all been fixed. So the high-low switch for the tone and the bright-dim switch have been reconnected to the radio. I do see some resistors here on the bright-dim switch, but it looks like probably all that is a dropping resistor, because he added an LED meter light to this radio, but it does dim. Because normally if you just take out the normal incandescent light bulb and stick one in, when you flip the bright dim switch, it doesn't change the intensity of the LED. They operate over a rather large voltage range and will keep the same intensity, so you really have to drop the voltage to get those things to dim. So I'm assuming inside that heat shrink tubing all I did was just added some series resistance to lower the voltage even more when it's in a dim position to you know, lower it on that. And then I can see some resistors down here on the CBPA switch, and that's, as I'd said in the note there he had, that's for his output power, for a low-high power switch. So the caps that he used, no complaints whatsoever. It looks like they're probably all Nichicons. There's VZs and PWs, I see. So you know, the VZ series, the black ones, the PW series, the brown ones like I use. There's some gold ones in here. Yeah, it looks like they're all Nichicons. I'll give it a close inspection, but yeah, it doesn't look like cheap caps were used, so no need to change any of those. They just got replaced. He's just mainly having receive problems, and we got to get this glue out of here so it doesn't cause any more future problems. So let me get to, this is probably the one thing I hate the most working on radios, taking glue out. It's such a laborious, boring process, honestly. So anyhow, let me get to it. Okay, so I thought I'd just really quick show. I pulled this module out, and what a pain in the butt getting this thing out, because this nut for this bracket is trapped in between there. So yeah, a little challenging. But what I wanted to show is, and like I said, I don't want to rag on Ralph for the boards. Well, actually I do, but I don't want to complain about how they work, because they work fine. But this is what I'm talking about. I can get a lot better close-up. Just move the camera down some too. Come on, focus, focus. And get my pointer. But we can see what I mean about homebrewed or etched boards. You can see It wasn't completely etched here. There's little ears, there's little specks of copper all over the place. If you look at the rest of it, you can see how rough it is. It's pitted through in spots. The traces are thinner than they need to be. It didn't put, again, being not professionally made, there's no or masking on the solder traces. So you can see this is all starting to turn black and grungy, so it's starting to oxidize. And you can see just how pitted the copper is. You know, yeah, if you're going to, this is fine for making your own stuff. You're making something you're going to use yourself. Hey, if it doesn't look fantastic, who cares? It's yours. If it breaks, you fix your own stuff. But if you're selling something to consumers, yeah, you should honestly, man, just get it over with and get some professional boards made from a professional board house. So. And like I say, the reason I pulled this out is I need to pull this out so I can add some extra filtering, because of course the power supply wire to this module is over here. So yeah, it's a bit of pain in the butt. It's a shame it's not this connector over here, but this is the signal input on this side. But let me add a little bit of filtering to this, and I can get this critter popped back in the box. Okay, so this is why you should take the parts out when you're removing the glue. It's the only way to get it all out, people. So I've removed a bunch of parts. A bunch of ceramic capacitors, a toroid transformer here, another ceramic cap, a jumper wire, a pair of ferrite beads, another ferrite bead, a poly dip cap. But you can see all the glue still down around there. That was still touching the leads. Now the glue that's on the board, honestly, it ain't doing nothing. It's probably not going to hurt anything. But right there at the hole where the component lead goes through, that glue's still touching the component lead. It's just going to continue to eat it off. Same thing over here. Probably the most fragile component in this entire radio when it comes down to the leads on it is the little toroid transformer right here. If we just move over here to the right a little bit, I've got all the parts lined up that I just took out. So when you're doing something like this, you can do it one at a time. A lot of times that may make it a little bit more difficult trying to get that glue out from around parts, but if you're afraid you're going to get stuff mixed up, do it one piece at a time's fine. I usually take out everything in an affected area and do it. But I'll check the leads. If the lead's corroded, I'll just stick a new cap in. It's not like these things cost that much. The toroid transformer, like I say, tiny little wires. The magnet wire used on this thing, they're tiny little guys. It doesn't take much corrosion, and those things, bink, they just pop off. So yeah, I'm not even gonna try to clean that one up. This one has so much goop on it. I'm just gonna rewind it. This wire here, the jumper wire. Why did he even try to clean that? Just take it out. Like I said, I've got a whole little tub here full of cut off leads that are perfect for doing, replacing that, and the one on here, and this one. Just take the ferrite beads off, clean the glue off of them, just shove a new wire in the hole. This cap here, probably going to replace it. Again, the leads, you can see it's all corroded right there. Don't even try. As cheap as it is, it'll end up costing the customer more money because it takes more time trying to clean all that gunk off of the lead than it will just putting in a new couple cent part. Now, when it comes to rewinding toroid transformers, or not even just toroid transformers, it can be just a coil if it's it has several wraps around a ferrite core. Count them. Try to be careful and see, especially if they use different gauge wires, because occasionally you'll have, and not just occasionally, quite frequently you'll have toroid transformers where it will be 2 different gauge wires on there. Just make sure you pay attention to which lead went into which hole. And then as far as where do you get magnet wire? Anywhere, people. I mean, I had these nice little kits. Remington Wire makes lots of nice little boxed wire kits. Here's one. That's all that is. It's just magnet wire. That's all that's in there. This box covers from 32 gauge to 22 gauge. You know, I'm not going to say there's a lifetime supply in there, but honestly, I don't wind that many of my own toroid transformers for projects, so about the only thing this stuff gets used for is for repairs. That's probably a decade or two's worth of magnet wire in that box right there. And it's convenient. I've got every size that I need, and if I need, just hold on a second, I'll grab the other box. I've got a box that covers bigger gauges. You know, so if I've got larger wire that I need, you know, I've got this box here, again, Remington wire, goes up to 14 gauge, but you know, same, now granted there's a little bit of overlap here, the 24 and 22 gauge, but still, this box covers from 24 to 14 gauge. You know, if I need a piece, I don't have to search around for it, or it's just here. You know, I do this for a living. I'm repairing radios for a living. I'm using this stuff all the time. Just buy an assortment kit, that way I'm always guaranteed to have it on hand. And these are convenient. Like I say, it makes dispensing very easy. There's no worry about all the label rubbed off of the reel, and then I have to measure the diameter of it to see if it's the right size. I just look at the box. Now, granted, I did write on the box. They don't come labeled with the holes, but you know, you initially get these, the wires. The spools are just in the box. You have to take a little piece of tape off and shove it up through the holes. And then I just wrote on the top of the box, though, what gauges it is. But like I said, it's just very convenient for doing stuff like this. So let me get to it. Like I said, I thought I'd show a little bit how I do that. Like I said, it's the easiest way for me to do it is just take the parts out. You're never going to get all that glue residue off around where those component leads go. And not only that, you have to remember that glue, or the solder connection for these components, is on the bottom side of the board. So that means that the glue has oozed down into these holes. So unless you remove these components, there's no way to get the glue out of the hole, because the glue will have oozed down into the hole around the lead. You can scrape off all the stuff up here you want, and it can look like brand new, and it can still corrode the lead off because there's still glue down inside that hole. And then to remove the residue down in that hole, I just use a pin vise or a hand vise that has a appropriately sized drill bit. So, you know, I just go down in here, find a hole I need to clean out, and this drill bit is just slightly oversized. So basically the next drill bit size down from this would perfectly fit through the hole. This one's just slightly bigger. It's a numbered drill bit, very small. And don't ask me what size it is, because that can vary from hole to hole. I mean, this is the one I use the most, but the holes in the board can vary depending what is going into those holes. So, you know, occasionally I do have to change it to a different size. But yeah, I just stick it down in a hole, pull, and then pull it up through. The hole's clean. I don't have to worry about if the residue soaked in a little bit into the circuit board material. Because the drill bit's a little bit oversized, it's actually enlarging the hole a little bit. So it's taking off a thin layer of the board material on the inside diameter of that hole. No more glue, clean off the top, it'll be just good as new. I can put new parts in there, or if the parts weren't, you know, the leads weren't bad, I can reinstall the parts and it'll never have a problem. The corrosion problem is fixed for eternity, basically. So there's just a few tips and tricks on doing this. You know, this really gets to the point of being annoying, I guess, when someone tells you they've cleaned the glue out, and man, it just, this thing's getting to be a pain in my butt. It's taking forever. I mean, this may be one of the worst I've seen. I said I don't think it was quite the worst, but yeah, it might be. Man, I've had to pull transformers out. They had so much glue down around the crystal filter and the crystal here. And, you know, someone had pulled a little bit of the glue off. Well, that doesn't do any good for all the glue that had oozed underneath of the crystal and is slowly eating the leads off of the crystal and the crystal filter here and both of these transformers. And just, yeah, it just, man, one after the other, you know. The ceramic filter, they'd done a good job of scratching the glue off the top of it, but of course didn't remove it, so there was lots of glue underneath of it on all the pins. VCO, yeah, I've got the VCO, a capacitor, I've got another transformer out, I've got a transistor and a resistor out over here. I mean, these things are just flat out plain, yeah, they didn't even take, now this stuff on here, honestly, doesn't matter. It's not touching anything electrical connection, you know. This is the stuff you're worried about, this stuff that's touching the pins. I mean, look at that. It's just slowly eating the pins off of this thing. And not only that, that'll cause shorts, because remember, when this glue turns this dark brown, it starts to become conductive. So it's like a resistor, and it'll start to short out pins here. You know, bottom of this transformer right here. The glue had oozed underneath of it, and it's, you know, touching pins. I'm trying to look through the viewfinder and not having a lot of success here. Hold on a second. Yeah, so come on, focus. You know, this pin here, you can see somebody scratched, not all of it, but most of the glue off the outside, but it had oozed underneath. So what's it doing? It's touching the pin. Now granted, it would probably take a few millennia to corrode that huge heavy pin in half. The problem is, right at the base of this pin, you have to remember, inside of this is basically the same as like this little toroid transformer, which I rewound. So, you know, here's the original wire off of that. The wires on this, they're thin. The wires inside of this, they're, well, not microscopic, but they are tiny, very, very fine wires, and sometimes they can be like the thickness of a hair almost. Well, they come up around this plastic form on the inside. They come up through these little slots on the side, and then they're wrapped around. There, you can actually see one right there. See that little wire? It comes up and then it wraps around this pin, and then it's soldered on. Well, what's that covered in? Glue. So yeah, there, as a matter of fact, you can see the wire right there. So it's just going to eventually eat that tiny little wire off and destroy this transformer. So that's why you got to pull this stuff out. You can't just scratch it off the outside and say, ah, that's good enough. Well, it doesn't matter if you got it off the outside. I mean, it's just a can. That's not an electrical, you know, connection really. So, yeah, back at it. You know something? This radio is really starting to get to the want to strangle it point. So I got all the glue removed. I did end up replacing the VCO block in this. Where the heck is it? Cleaning the pins off. And yeah, these last two pins were so corroded, I barely touched that one, and bink, and yeah, it just snapped off. So yep, it's got another VCO block in it. But so I stuck that in, cleaned the bottom of the circuit board, because yeah, it was just nasty with soldering grunge. So you can see nice and shiny now. Once I did that, it was very easy to see that yeah, there was about, I don't know, a dozen and a half, 2 dozen solder connections on here that needed to be addressed. It looked like 1 or 2 of them were just completely broken out. I'm not sure how in the heck this thing was working, so they were apparently making some contact, but yeah, the parts were no longer actually soldered to the board. Got all that done, fired it up, and nothing. Well, I had a little bit of received static, I'll put it that way, but no transmit, and it would no longer change channels. Didn't matter if I was using the channel selector here or the channel modification here. And then it dawned on me, this little board right here. I think I had shown before where and now having to deal with this board, it's really one of those annoying things, man. That's why I say, yeah, this etched homebrew board with the really narrow traces, maybe not such a great idea. You know, obviously there had been problems because someone had already had to bodge in a piece of wire across a broken circuit trace already. And I don't know what that corrosion was there. I don't know if whoever installed this wire, because it was right in the location where at this end of this little wire where it was corroded all around in that area. Maybe they used acid core flux. Got me, man. But in any case, so I cleaned that off, and all I did was, and I don't even know where in my shirt pocket, yeah, my little fiberglass brush. And this is the one that has a nice fluffy bristles. This isn't like my Russia Racer, which, man, that thing will chew through a piece of aluminum plate. This one's nice. You can see I'm running my fingers over it. It's nice fluffy bristles, but it's really good for cleaning off light oxidation. Doesn't really do a lot of damage, or really at all, to copper traces or any other soft metals. But it's really good at getting the oxidation off. And I just brushed that across there a couple times. So, yeah, I did a little bit of troubleshooting, and the VCO voltage was just stuck at like 6.7 something volts. Wasn't going anywhere. Thinking in my mind, well, I did just change the VCO block, so possibility it's bad. I doubt it, but anything's possible. And that's when I remembered, the corroded traces. So sure enough, put on some needle probe tips on the end of the probes here, check it with an ohm meter, and yeah, 2 of the traces were no longer making contact. And I looked at them under a microscope, and yeah, sure enough, they were just corroded. They were just barely making contact underneath of that corrosion. And when I cleaned it off, it finished it off. So I've been sitting here for the last several minutes repairing circuit traces on this, what I can only assume is a almost brand new board. Come on, hocus pocus focus. So what I've been doing, and it's the easiest way to do stuff like this, is just use Kynar wire. Kynar wire, you can get it in different gauges, but it's very, very thin stuff. So what I'm using here is just 30 gauge, so very small. I mean, you can see it in comparison to my finger. It's really tiny. And actually, once you strip the insulation off, I can get this little tiny piece picked up. Of course, the conductor in there is even smaller. It's kind of like this strand of wire. It's about the size of a strand of wire, because actually a lot of your stranded wires, that's what they use. Stranded wires are made up of several 30 gauge wires. But what you do is just use some, and I like Kynar wire, because the problem is when you start getting into small wires, the instant you try to solder something like that, there's hardly any insulation there on the wire. It just melts away. Kynar wire has a very, I honestly don't think it's Teflon. But it acts like Teflon. I would have to assume Kynar. I'm assuming that's what the Kynar stands for, is the type of insulation. But it's extremely high heat resistance. So you can solder this wire and you don't have to worry about the insulation melting back, because that's the problem you'll have when you use regular like PVC or any of the normal wire insulations. But yeah, so I ended up replacing, and you can just barely see them in here because they're so small, but there's a piece of wire right there. There's one from here to here. I repaired this one. This is the one where someone had a jumper wire, just kind of a big hoop hanging up underneath of here. And that actually was bouncing back and forth because the entire pad's ripped off here, and that's where, on the underside here, where all of these wires attach. And it was kind of folded over and looked like it was almost shorting against this trace. And I also replaced this one. But yeah, it's not hard to do. Just desolder the connection on either end. Then you can cut off a piece of Kynar wire, strip it, so it's basically the exact length in between the pins there, the insulation's left. And then I just used 2 pair of tweezers, one to hold it down, and one I just wrapped the wire around one lead, solder the end. But the nice thing is, it stays down really flat against the board. And then just lay it down, and same thing, just wrap the wire around the end there, solder the end. But yeah, there you can actually see it a little bit better. But so now I can put this back in again. Actually, I got to solder the ground connection, because it had a ground connection going from here down to the can, right, or actually was it the can? No, actually it had gone to the crystal right there, which goes down to the can here, and then down to DC ground. But yeah, so I need to get that soldered back on, and then see if the radio works. Like I say, man, it's just some sloppy work in here, and man, these boards. Ralph, you gotta do something about these boards, man. That's just, yeah. Today's cheap boards, professionally manufactured. I mean, here, let me just grab one to show you what I'm talking about. Good quality boards. Like I say, I'll grab one of Mark's boards to show you what I mean. Here's a unpopulated one. So, this is for kind of like something like this, doing channel modifications. This is a adapter board for a UPD 858 PLL. But good, man, that's FR4 board. You can't bend this stuff, man. It's just, good high quality, through plated holes, nice heavy construction. I mean, and it doesn't have, it can be, they don't just do simple stuff. They do, more complicated, because here's like a unit in 858 channel expansion board. Or not 858, the 980, my God. Got the brain on this radio. The Bearcat 980. You know, this circuit board itself, Mark gets these made by Elecros. They're made in China, but again, good high quality board. They do a really nice job. I mean, the silk screening, do a nice job of the silk screening. I've never seen a problem with any of these. They work, you know, really well, and they're very, very reasonable. And they can do more than 2 layers also. You know, I think Elecro can do, don't hold me to this, have to go to their website and look, 6 or 8 layer boards, and they may be able to do more. I just, off the top of my head, I can't remember. But, let me put my box back over here. But, like I say, boards like this, fine if you're making them for yourself, but if you're going to be selling stuff to people, get professional boards made. You have a much better reputation. Looks more professional, you know, and you don't have problems like this, which just end up giving you a bad name. So, let me get her put back together here again, give her a try, and see if my VCO voltage actually changes with the channels and the radio works again. Okay, so I do believe she's pretty much done except for the last little bit of cleanup on it. Only so much I can do for that. Yeah, the bezel's pitted, the chrome's, if you can hear that, the chrome's actually starting to bubble up and peel off of the faceplate. So, yeah, it's not a, you know, cosmetic beauty queen, but she works now, and it receives like it should. So, added some extra filtering for the frequency counter. The radio is on, and the squelch is actually turned up right now, and I really don't hear anything out of the speaker, where there was that frequency counter buzz before. So adding a little bit of extra filtering pretty much almost completely eliminated that. So, you know, I can turn the squelch down. You can hear. Got all the rest of the glue out, like I had said, replaced the VCO block. One other thing was the meter was kind of falling into the radio. The little plastic bracket was in 2 pieces, and the center of it was missing, so I replaced that. So now the meter is not falling into the radio. Other than that, I think the only other, I mean, I've removed all the audio modification, so you can see there's lots of green capacitors back here now. You know, the proper value of poly-dip capacitors, a bunch of resistors were changed. I honestly don't know what someone was doing in the AM regulator circuit, but I also found a couple of resistors had been changed in the AM regulator circuit for some unknown reason. They had some capacitor bodged on the underside. I don't know what the heck they were trying to do. You got me. I just put those back to stock values. I did the alignment on it. Set the carrier for 4 watts. Now remember, this has the CBPA switch set for, or it had been changed over to a high-low power switch, and he said it was supposed to be 4 watts when it's in CB, and when you put it in PA, it was supposed to be 2 watts. It wasn't. It was high, and all they had done was basically installed, you know, a set of wires that went back, but they tap into the AM carrier adjustment that's already in the back of the radio here. And they added some resistance across the set of switch contacts on this switch. So when you put it into PA, it just reduces the level before it even gets to that control. So what I did was made it adjustable. Now it's on the inside of the radio, but that PA setting is now adjustable. So I took the 2 resistors that were on the back of the switch. I took those off. They're in a trash can. And I installed a 10-turn trimmer resistor. I don't know if I'll be able to get this camera view here. Try and zoom in a little. Yeah, you can just see it. Right there. You can just see little brass screw heads sticking up out of it. But there is a 10-turn Allen Bradley trimmer potentiometer. So now if he ever wants to change that to a different level, he can just go in there, adjust that to set the PA level to whatever he wants. It's, like I say, it's internally adjustable now. Other than that, I think the only other, I mean, I've removed all the audio modification. So Other than that, like I say, the caps that he had put in here were fine. There was nothing wrong with the electrolytic caps. That was fine. It cleaned all the goop off the bottom of the board so I could actually inspect it. A lot of reflow work, man. There were just so many bad solder joints on this. But not surprisingly, older radio had been used in a truck for a long time, and I'm not talking about a pickup truck. He's a truck driver, so yeah, this has been used in an over-the-road truck for a long time. So, they take a lot of abuse. All the parts, the only thing holding these parts in this radio, because you got to remember, it's upside down right now. So, when you flip this radio right side up, the only thing holding all these parts in this radio is the solder. It's gravity's always pulling down. All these things are, when you flip the radio over, they're all dangling. So, yeah, every time you hit a bump, they're trying to rip themselves out of the radio. It's not uncommon to see bad solder joints, especially in an older, very, very early 1980s radio like this. So, that's been taken care of. It shouldn't have any more problems. The channel modification board, like I say, I got the just the circuit traces on this. I won't even get back into that again. But now how that works, how the what the heck is it? Backwoods RF or Ralph's channel modification board works. Right now I have it set to where you turn the channel selector, you can see on the frequency counter. Now remember, that's two separate things. There's the little board over here on this side in this box, and that's the channel modification. And then the frequency counter is just that. It's a separate frequency counter module. But as you can see, we'll get up to channel 40, and I flip one more time, and the channel display on the radio still works. So you can see there's a 40. Kind of hard to see the O, but if I continue to channel 1, goes to 26965. Now, if you want to use the VFO to get the full capabilities, basically out of this PLL, you just push the rotary encoder, and now it operates off of this. You can turn the channel selector here all you want. It doesn't do anything anymore. So, this gives you like 28 something. Let's get up here. Remember how high? Oh, okay, it flipped over. So 28085 to 26845. Actually, it looks like, yeah, actually, that's the VCO's having a hard time. I can see it's bouncing around there. So the VCO's actually having a hard time locking on that channel right there. Yeah, it's unlocked. Yeah, so there it's locked. It's locked there. It's locked there. Yeah, it starts to, the VCO unlocks at around 26.8. I guess that'd be 4, yeah. So anything under 26.845, the VCO is starting to unlock. But yeah, it's only what, like three channel positions. So, and then if you want to go back to using the channel selector, you just again hit the button, and now you're back to using the normal channel selector on the radio. Now the only thing is this. I think like somebody breaking through squelch there.
Well, I'm hoping it stays running up that way. Got to go back over to New Holland.
So there you can see she's actually receiving. No skip today. Yeah, it's dead as a doornail. So yeah, it's just local truckers on channel 19. Now the one thing about these frequency counter modules, when you change your mode over to sideband, the display is going to be off by 1.5 kilohertz. So if I flip to lower sideband, you're going to see the frequency is displaying 1.5 kilohertz low, and if I flip to upper sideband, you'll see it's reading 1.5 kilohertz high. That's your sideband offset. That's because where the frequency counter is getting its sample in here includes that offset, but the frequency count and the frequency counter has a offset programmed into it. These counter modules, basically out of the box, if you hook it up to let's say a 10 megahertz signal, it'll read 10 megahertz. But what's coming out of this radio and feeding the frequency counter is not in, if we put it in AM, so what's coming out, the sample in here is not 27.185 megahertz. What's coming out of here is going to be the tripled frequency, 34, shoot, I'm going to grab the service manual here. I can actually tell you what it is. We have the old Sam's manual. So yeah, channel 19. Matter of fact, we can look at that and you can see So, if we go to channel 19, you can see here's our PLL programming, which pins, but it would be 34.985 is actually what's going into that counter module over there. But as you can also see when you flip in, so you've got your upper and lower sideband output, you can see that frequency is different. And that's why that frequency counter, when you switch into upper or lower sideband, it's off by 1.5 kilohertz. That's why. So you just need to know that when you flip into lower sideband, whatever you see on there, add 1.5 kilohertz. If you're in upper sideband, subtract 1.5 kilohertz. So that's pretty much it. Good receiving radio now. Transmits good, right at 100% modulation. Actually, I had trouble getting the 100% modulation. I guess that was some of what they had been doing in the regulator circuit. Of course, they had all these audio mods in here, but some of the other work they had done in here, they had changed some values in the AMC circuit and whatnot. All those resistors were put back to the proper value in here. Once I did that, the modulation adjustment was easy to get back in at 100%, so it wasn't over-modulating. But yeah, so there wasn't a lot of other stuff done to this. It's not like there were a lot of other cut-out parts. He said receive, I guess the person that worked on this last told him it had a receive mod done to it, but it didn't have the normal receive mod. Normal receive mod would be the first RF amp replaced, maybe some Schottky diodes. Yeah, it didn't have any of that. That's all, and still is original. Yeah, no need to do those. These are great receiving radios when you do a proper alignment on them. So there you go. There's a nice early Cobra 148 GTL back up and running. I mean, it was working before, it just wasn't working all that great. But it's up and working as it should be now.